Okay, so the first thing that we're gonna see today is how to identify like what geometry is happening behind like a matrix. So like this skill, how does this skill looks like? Like I am gonna give you a matrix like A B C D, and you need to tell me, oh, o sea, depending on what numbers you have in here, you're gonna be able to tell me like, oh, this may be a rotation by a certain degree. This is a reflection by a certain line, or this may be a dilation, no, by a certain factor. O sea, I am gonna give you the matrix, and you need to classify, like, what is the geometry happening behind, no? So, uh, first of all, let me talk about like this formula that appears in the formula booklet. That is the formula of the determinant. This is not the first time that we've seen it. So the determinant is the will tell us what type of transformation is happening behind the matrix. Like if I give you a matrix A B C D, o sea, if I give you a matrix A B C D, and this is not in the formula booklet, if the determinant of A is 1, that means that A is a rotation. If the determinant of A is -1, A is a reflection. And if we know that the determinant of A is a certain value k, then A is a dilation. So with this, we can classify what type of what type of transformation we're dealing with. So just remember that this, and be careful because this, not in the formula booklet. This is not in the formula booklet. Okay. Um, okay, so what it is in the formula booklet is the following relations, no? Like, for example, this is the shape of a matrix that it's a reflection. This is a formula for a horizontal stretch. This is a formula for a vertical stretch. This is a formula for an enlargement. This is a formula for a anti-clockwise rotation, and this is the formula for a clockwise rotation. This is in the formula booklet. This is actually like a screenshot from your formula booklet. So, for example, let us look at this matrix. This matrix, if I do the same that I was saying, no, like, so this is very obvious an enlargement, no, but let us do it baby steps. O sea, if I do the determinant of this matrix, o sea, the determinant, if I call this A, the determinant, o sea, if I do the formula, I can also do it in the calculator. It is AD, o sea, 3 times 3 minus BC. No, because remember that it is A, B, C, D, o sea, AD minus BC. AD minus BC. And so the determinant in this case is a 9, which means that this matrix is a dilation. Okay, now that I know that it is a dilation, I go to my formulas and I compare. What type of dilation is it? Is it an enlargement that has a number and a 1? Or is it an enlargement that has the same number in the diagonal? Because it has the same numbers in the diagonal, that means that this is an enlargement. O sea, what is this? This is an enlargement with k equals 3. In the same way, this one, it's very clear that this is also an enlargement with k of a fourth. So this means that this is a very particular type of enlargement, no? This is a compression because like by multiplying by a fourth, I am making it smaller. Okay, so for this two, it was very easy. Like, I did not even have to check the determinant rule, no? But let us say what happens for this one. So for this one, if I do the determinant rule of this matrix, so it would be the determinant of A, or bueno, x prime, it would be 0.6 times 0.6 minus 0.8 times minus 0.8, no? I am doing 0.6 times 0.6 minus 0.8 times minus 0.8, no? And okay, this number is clearly positive, and so actually, if you do it, this is 1, no? You can check it with the calculator. This is 1. Okay, so I know that this matrix is a rotation. Okay, now I need to find out what type of rotation is it. If I go to the rotation formulas, look that is the rotation anticlockwise has a negative here in the upper left side, and the rotation clockwise, I said counterclockwise, has the negative sign upper left, and clockwise has the negative side is the bottom right. So here, this one has a negative sign bottom right, so that means that this is a rotation clockwise, no? This is a rotation clockwise, and now I need to find the angle. So I know, kids, that that this formula is the formula for this matrix, which means that there is a certain correspondence, no? This entry is the same as this entry. This entry is the same as this entry. This entry is the same as this entry. And this entry is the same as this entry. So that means that I can write an equation, no? I could write the equation, from yellow, I could write cosine of theta equals to 0.6. And if I do the calculator, I go to the calculator, look how cool is this, oh my god. So if I know that cosine of theta equals to 0.6, then I just need to do inverse cosine of 0.6. Check that my calculator, I'm going to put it in degrees. So that equals to, that means that theta equals to 53.13, no? I'm going to round it as 53.1. Okay. So this is a rotation clockwise with an angle of 53.1 degrees. Amazing. Now, for example, look at this one. If you do the determinant rule, again, I do the determinant, no? So the determinant of A1 is 1/2 times 1/2 minus square root of 3 over 2 times negative square root of 3 over 2. This is 1/4 plus 3/4. This is 1. So again, this one is a rotation. And now I need to check, where do I have my negative sign? I have my negative sign in the upper left side. So that means that this one, no? So now this is a counterclockwise. This is a counterclockwise rotation. And if I do the match of this with this formula, entonces, for example, I'm just going to do 1, no? Like, for example, this yellow one goes with this yellow one. This green one goes with this green one. This blue one goes with this blue one. And so on. No, the red one goes with the red one. So I can write the equation. I can write the equation cosine of theta equals to 1/2 So theta equals to inverse cosine of 1/2, which we all know it is 60. Is it 60? Um, it is 60. Nice. Okay. With theta equals 60. I'm just going to do a couple more. So, for example, uh, this one is interesting, I feel. How do I add? I'm going to add a dotted paper, yeah. So let us try to solve. Whoa, whoa! This is so technological. I feel so technological. Okay, so this one, if you remember in class, we were struggling with this guy. Uh, so what type of transformation is it? If I do the determinant rule, I am gonna call this A. The determinant of A would be -3/5 times 3/5 minus 4/5 times 4/5. So that means that this would be -9/25 minus 16/25, o sea, this is -1. So this is a reflection. If this is a reflection, it means that, well, it has the form, it has this form, no? Cosine, sine, sine, cosine, but with a 2. O sea, it has the form cosine of 2 theta, sine of 2 theta. Is it negative? No, positive. Sine of 2 theta, sine of 2 theta, negative cosine of 2 theta. Okay. So, again, I can do the correspondence between this and this, between this and this, between this and this, and between this and this. So I can write an equation. No, my equation would be a cosine of 2 theta equals to -3/5. That means that 2 theta equals to the inverse cosine of -3/5. If I go to my calculator and I find the inverse cosine of -3/5, that is 126.87. So 2 theta equals to 127. Oh no, I'm gonna do it. 126.87. That means that theta equals to 126.87 over 2, which is 63.4349. So this is my angle. Okay, but like, look at the formula. So the formula here in the booklet, it says that it is reflecting over the line y equals tangent of theta x. So if I do, so it is a reflection by the line y equals tangent of 63.4349 x. And what is the tangent of 63.4349? That is 2. So that means that this is a reflection. This is a reflection by the line y equals to x. I'm sorry. So this means that this is a reflection by the line y equals to x, because this is 2. And what is this? This is the slope, no? O sea, 2 is the slope. Okay. Okay. So, for example, now that we have this logic, let us do, I don't know, like for example, this one that we did in class. Look at me. being so technological, like, wow, wow, Mr. Cachoa. This is amazing. This is amazing. So I'm just gonna paste it here. Okay. So again, I'm gonna call this A. And first, let us do the determinant rule, no? So the determinant of A is gonna be AD minus BC. Entonces, AD is negative 3 over 5 times 3 over 5 minus negative 4 over 5 times negative 4 over 5. So this is again negative 9 over 5 minus 16 over 5. Ajá. O sea, this is negative. Am I doing it wrong? Ay, Cachoa, of course you're doing it wrong. You don't know how to multiply your fractions, Mr. Cachoa. This is negative 9 over 25 minus positive 16 over 25, no? And so this becomes negative 25 over 25, which is again a reflection, no? O sea, this is negative 1. Of course, you can do this one with the calculator, no? But we're mental math people. So this is again one of those formulas that is, o sea, that means that my matrix is cosine of 2a, sine of 2a, is cosine of 2 theta, sine of 2 theta, sine of 2 theta, cosine, negative cosine of 2 theta, no? So that means that I can set the equation negative 3 over 5 equals to cosine of 2 theta. So cosine of 2 theta equals to negative 3 over 5. And isn't it the same? It is the same. Is it the same? Did I do the same one twice? No, I did not. I did not. I did not. I did not. So, so this means that, o sea, like theta again is 63.4349, no? O sea, I have the same equation. So that means that this matrix and this matrix, o sea, do the same transformation. This is a reflection by the line y equals 2x, no? O sea, like, observe that it is the same, no? Cool. Cool, cool, cool. Let me do a rotation just for us to finish with this. So, which one is a rotation? Which one is a rotation? I think that it is very clear that this one is a rotation. Wow. Still amazed, surprised. Wow. So if I put this here and I call this one A, so I do the determinant rule. That is negative 1 square root of 2 times negative 1 square root of 2 minus 1 over the square root of 2 times 1 times negative 1 over the square root of 2. O sea, this is 1 over 2 plus 1 over 2. O sea, this is 1. So this is a rotation. Okay, and look, I have a negative in everyone except in here. So like, I know that if I have a negative in here, this negative means that it is anti-clockwise. So this is something that I did not, this is something that I need to tell you. What I can do is that I can pull out a negative 1, no? So I can pull out the negative 1, and this is 1 over the square root of 2 minus 1 over the square root of 2, 1 over the square root of 2, 1 over the square root of 2, no? And so when I am pulling, I I am factoring this negative 1. O sea, now this looks very clearly, o sea, please verify that the determinant does not change. This is as well a rotation, because if you do 1 over the square root of 2 times 1 over the square root of 2, that is 1 half. And this times this is negative 1 half. So 1 half minus 1 half, that is 1 half plus 1 half, that is 1. So this is a rotation as well. Please observe that, so what is, o sea, so this is cosine of theta, negative sine of theta, sine of theta, cosine of theta. So I can write the equation. I can set the correspondence to be like this 1 square root of 2 equals to the cosine. And so I know that cosine of theta equals to 1 over the square root of 2, which means that theta is 45 degrees. Okay, but there is a problemo. What is the effect of factoring that negative? And Corin was asking me, like, but Mr. Kachua, what is the effect? What is the effect of factoring that negative 1? Well, if I need to factor a negative 1, so the effect is I need to add theta plus 90 degrees, ¿no? O sea, perdón, plus 180 degrees. And that has a very weird and interesting explanation. O sea, because if you multiply, o sea, imagine that this is a weird explanation. So 0, 1, 2, 3. So what happens when you multiply 2 by negative 1? When you multiply 2 times negative 1, it makes like a rotation of 180 degrees. O sea, this movement was a rotation of 180 degrees. So like this negative 1 represents 180 degrees. So I am rotating 45 degrees, and because I have a negative, that is 45 plus, o sea, my final angle would be theta, my final angle, o sea, my angle would be 45 plus 180, o sea, it would be 225. Okay? Let me do the other one, no? What if I do, I think that this one, no? What is this one? So what is this one? So again, let us check. I do the determinant, no? So I need to do negative 1 half times negative 1 half minus the square root of 3 over 2 times negative the square root of 3 over 2. So here I have 1/4, and here I have positive 3/4, no? O sea, this is 1, so this is a rotation. Okay, in this crazy rotation, I don't have like I would like to see if this one matches either this or this. And I can see that again, because I cannot match it, I need to pull out a negative 1. So I pull a negative 1, and so this becomes 1/2 negative square root of 3 over 2 square root of 3 over 2 1/2. So I do the correspondence with the matrix cosine of theta, negative sine of theta, cosine of theta. And by doing this correspondence, by matching this one with this one, I can see that again, is it the same? Am I doing this twice? No, no. So so the equation that I would need to write is cosine of theta equals to 1/2. I go to my calculator. Ah, inverse cosine, here I have it now, inverse cosine of 1/2. So I know that that means that the theta is 60 degrees. So my final angle is 180 plus 60 degrees, which is 240. Okay, so this is my first skill.